Infinite rods of uniform mass density means mass per unit length is a constant and length are given L, L by 2, L by 4 up to infinite. That means the center of mass of the system, suppose the center of mass of the system is a RC, then RC is the sum of the MR, moment of the sum of masses upon total mass. Here we want to find the x coordinate. Therefore the x center of mass is equal to, suppose the mass of the first rod is a capital M whose length is a L, but the center of mass of this rod is at the L by 2, so it is M multiplied by L by 2. Similar, next is a mass is a M by 2, but the center of mass at the L by 4, and again the mass is M by 4, but the center of mass is at the L by 8. Upon total mass is a, that is up to infinite, and the total mass is the M plus M by 2 plus M by 4 and so on up to infinite. Therefore the x center of mass is equal to M into L. In the bracket it is half plus 1 by 8 plus 1 by 32 up to infinite, and the m कॉमन ले लें नीचे से, तो डिनोमिनेटर में तो m कॉमन आने के बाद it is 1 plus half plus 1 by 4 and it becomes again GP. In the numerator the sum of the GP is the first term is 1 by 2 and the ratio is a 1 by 4. That ratio is a 1 by 4, so the 1 minus 1 by 4, so it is a 3 by 4 means 4 by 3 into 1 by 2, so it is a 2 by 3. Or sum of the GP of in the denominator is a 1 plus half plus 1 by 4. It is a first term is a 1 and here ratio is a 1 by 2, so it is 1 minus 1 by 2 and that is a 2. If you put the value in the x center of mass is equal to, इसका value put करें, then it is a L multiplied by, it is a 2 by 3, and the in the numerator is only 2, so 2 cancel with the 2, it is a L by 3 is the x coordinate of the center of mass. That's why it is a second is a correct. Also x coordinate निकालना है, the x coordinate of the center of mass. Total identical 4, there are 4 bricks, सभी का mass m है, so the center of mass का location r center of mass is equal to sum of the mr that divided by total mass. Here we want to find the x coordinate, so x coordinate of the center of mass is equal to total mass is a 4m and the center of mass of the first brick is at the L by 2, so first brick का L by 2, second का L by 2 के बाद again L by 2 पर होगा, it is a for the second, and थर्ड ब्रिक के लिए L by 2 प्लस L by 4 के बाद L by 2 पर होगा, so it is a for the third brick, and the last fourth brick के लिए L by 2 plus L by 4 plus L by 6 and plus L by 2. इन सभी को सम करें तो मास m से m कैंसिल कर दें, x सेंटर ऑफ मास इक्वल टू, here the this is L by 4 and the L by 4, that is L by 2, so 1 L by 2, 2, 3, 4, 5, 6, 7 and 8 L by 2 means it is a 4L plus L by 6 plus L by 6 and that is whole divided by 4, so it is a 25L by 6, 4, 24, 25L by 24, so the correct option is the second one. Given situation, a circular disc of radius r and triangular portion is a cut, then the distance of the center of mass of the remaining disc from the center of mass of the disc. So first of all यदि हम इसके center of mass को मार्क करें तो इसके कोऑर्डिनेट जो आएंगे that is r, 0 and that is 0 minus r, 0 and that is 0, r. So what is the centroid of the triangular plate? Centroid of the triangular plate is a 0 comma r by 3. So what is the height of the centroid of the triangular plate? Is a 0 comma r by 3. और वैसे भी इसमें y axis symmetric axis है. Now what is the total mass? Total mass is a capital M, and the mass of the triangular plate which is taken out, total mass divided by total area is a pi r square. Suppose the radius is r, and the area of this triangular plate is a 1 by 2 into 2r into, so it is a m by pi. So here the masses of the disc is a capital M, and mass of the removing triangular plate is a m by pi, and it behaves like a negative mass. So now we can calculate the y center of mass is equal to, positive mass is m, negative mass is m upon pi, and we know from this point O, this coordinate is 0, and but this coordinate is a r by 3, and that is divided by total mass is a m minus of m upon pi. So y center of mass equal to minus means डाउनवर्ड जाएगा, m से m कैंसिल कर लें, इट इज़ अ माइनस ऑफ r बाय 3 पाई in the bracket 1 minus 1 upon pi. If we multiplied this term, then minus r upon 3 pi minus of 3. So negative side y या distance की बात करें, distance of the center of mass of the remaining portion is a r upon 3 pi minus 3. Negative sign का meaning downward. I think correct option is a fourth one. यहाँ ये बोला गया कि यूनिफॉर्मली थिक प्लेट है जिसका शेप इस एरो की टाइप से है. तो यदि मैं इसका पूरे को एक ट्राइंगल लेता हूँ तो इसमें से ये जो पार्ट है दैट विल बी द रिमूव्ड, एंड रिमूव्ड पार्ट को नेगेटिव एरिया या नेगेटिव मास लेकर यदि मैं इसका सेंटर ऑफ मास निकालता हूँ तो मुझे ओ से इसका लोकेशन मिल जाएगा. तो क्यों ना मैं ओ इसी पॉइंट से ले लूँ. तो ओ इसी पॉइंट से लेते हैं, इसका कोऑर्डिनेट 0,0 आता है और इसका कोऑर्डिनेट 9,3 आता है और इसका कोऑर्डिनेट 0,6 आता है, एंड इस वर्टेक्स का कोऑर्डिनेट 3,3 आता है. यहाँ ये तो क्लियर है कि टोटल एरिया यदि होल एरिया लेते हैं सो इट इज़ अ 3 into 9 27 इज़ अ टोटल एरिया, एंड द A2 जो कि यहाँ से निकाला गया है या यहाँ पर है नहीं, उसका एरिया यदि मैं लेते हैं तो इट इज़ अ 9. वैसे भी सिमेट्री है, सिमेट्री अबाउट दिस एक्सिस, इसका सेंटर ऑफ मास इसी पॉइंट पे होगा. यदि मैं टोटल ट्राइंगल का सेंटर ऑफ मास या सेंट्रोइड निकालता हूँ तो इसके सभी के एक्स कोऑर्डिनेट ऐड करके 3 से डिवाइड करते हैं. इट इज़ 3,3 + 0 + 6 9/3. 9/3 इज़ अ 3. इट इज़ C1 एंड C2 जो कि रिमूव किया गया है या नहीं है, प्रेजेंट नहीं है, उन सभी के एक्स कोऑर्डिनेट ऐड करते हैं तो इट इज़ 1, 0. 3 + 6 9. 9/3 इट इज़ 3. सो इट मीन सिमेट्री है. सेंटर ऑफ मास y = 3 पर प्रेजेंट है. यदि इसका एक्स कोऑर्डिनेट निकालते हैं, हम एक्स कोऑर्डिनेट निकालते हैं तो इट इज़ अ 27. इट इज़ मल्टीप्लाई बाय 3, बट नेगेटिव एरिया जो कि प्रेजेंट नहीं है, शेडेड पार्ट इज़ रिमूव्ड. इट इज़ 9 into 1, and that is divided by 27 minus 9. So x coordinate is a 27 minus 9, that is a 18, and that is a 81 में से यदि 9 को सब्ट्रैक्ट कर लें हम, then the position of the center of mass with respect to the point O, इस पॉइंट से हमें सेंटर ऑफ मास की लोकेशन मिल जाएगा. इट इज़ अ 72/18. इट इज़ अ 4 सेंटीमीटर आई थिंक. यदि 4 सेंटीमीटर इस वाले पॉइंट से है जो कि हमने माना है, इससे 4 सेंटीमीटर होने का मीनिंग ये हुआ कि जो पूछा है वो कौन सा पूछा, वो इससे हमें पता है कि ये 3 ऑलरेडी है, सो इससे 1 सेंटीमीटर होगा. सो द करेक्ट ऑप्शन इज द फर्स्ट वन. In this question, the sector cut from a uniform disc of radius 12 centimeter and a uniform rod is bent into the shape of an arc. Then we know the center of mass of an arc which make angle theta on the center. Then the radius is a suppose a small r. Then the position of the center of mass from this point is a r sine theta divided by theta. And for the sector of the disc, similar, if the radius is a capital R, then that is a 2r sine theta divided by 3 theta. That is the position of the center of mass from this point. In this situation, both the angle will be same. Angle दोनों का same है. Suppose the radius of this sector is a capital R and the radius of this arc is a small r. And the condition is given कि इनका center of mass जो है origin पे होना चाहिए. It means the center of mass of the arc is at a distance, suppose r sin theta by theta. मास दोनों का सेम है. It means m1 r1 2r sin theta by 3 theta, and that is equal to m into small r sin theta by theta. m से m कैंसिल करेंगे, थीटा कैंसिल होगा, sin theta कैंसिल होगा. Capital R is the radius of this sector, is a 12 centimeter. So R equal to 2 into 12 divided by 3, so it is a 8 centimeter. Correct option is the first one. Question: the lamina is made by the removing small disc of radius 2r. This is a removing part, and the uniform mass density and radius is a 2r as shown in the figure in the first diagram. In the second diagram, जिस जगह कैविटी है, जिस जगह निकाला उस जगह एक डिस्क रखा है, बट द इंस्टेड ऑफ होल जो डिस्क रखा है उसका डेंसिटी जस्ट डबल है. इट मीन्स यूँ कहते हैं कि फर्स्ट वाली कंडीशन में पूरा मास पॉजिटिव है में, इसमें से रिमूव्ड मास जो है उसका रेडियस हाफ है. हाफ होने का नेगेटिव मास कितना हो जाएगा, दैट विल बी द m/4. और फिर ऐसा भी है कि यहाँ पर इस जगह जो मास रखा है वो इसका डेंसिटी जस्ट डबल है. इट मीन्स इन दिस सिचुएशन सेकेंड वाली में मास जो है 3m/4 एज वेल एज एक मास यहाँ रखा है, इसका ट्वाइस, जस्ट नेगेटिव फर्स्ट वाले केस के नेगेटिव मास का ट्वाइस कर दूँ, सो इट इज m/2. So we can say total mass in the second situation is 3m/4 and m/2. In the first case it is a m and negative mass is a minus m/4. So the coordinate of the first case is a y center of mass in the first case is equal to m. इसी origin से लेते हैं तो m into 0 but minus m/4 multiply by r, and the total mass is m minus m/4. So it is a minus of r/3. In this situation, second situation में बात करें हम, then y center of mass in the second situation 3m/4, जिसका कि हमने अभी center of mass निकाला है, वो कितना डिस्टेंस पर है इससे नीचे की तरफ, कितना r/3. So इसका कोऑर्डिनेट माइनस r/3 एज वेल एज सेकेंड जो m/2 ट्वाइस ऑफ द डेंसिटी है, इसका कैविटी जो निकाला उसका ट्वाइस डेंसिटी. इट मीन्स मास इज अ 2 times of the m/4 and the distance is r, and that divide by total mass is a 3m/4 plus m/2. Then y center of mass in the second case is a 3 से 3 कैंसिल कर लें, it is a minus mr/4 and plus mr/2, so it is a mr/4 divided by it is a 5m/4. So I think r/5 is the second. डिस्टेंस पूछा है, डिस्टेंस पहले केस में r है, that is r/3. In the second case that r dash equal to r/5, and पूछा क्या गया, 5 time of the r dash, and 5 time of r dash divided by r, the 5 time of the r/5, and that is divided by r/3, then it is equal to 3. So the correct option is the first one. In the figure shown, the small prism of the mass m slides down on the bigger prism of mass 5m. The mass of the prism is 5m and this mass is at m. In this condition, the force along the x-axis equal to 0. Therefore, the center of mass or the displacement of the center of mass along x-axis will be 0. There is no displacement along the x-axis, but the downward force is mg, that is due to gravity, means center of mass downward shift होगा लेकिन horizontal direction में shift नहीं होगा. But ये जब this block which displaces from top to bottom, then the displacement of the block with respect to ways is equal to not 5L, it is a 4L direction in this direction. And suppose the displacement of ways with respect to ground is equal to suppose x, then the displacement of the block with respect to ground is a 4L minus x in a right hand side. Then we can say m1 x1 equal to m2 x2, one of the in the positive side and second is in the negative side. What is the m1? M1 means it is a 5m and displacement of the ways with respect to ground is x, and that is a displacement of the block with respect to ground, that is a with respect to ways 4L, so it is 4L minus x, and mass of this block is a capital M. Then we calculate the m cancel, 5x plus x is a 6x equal to 4L. Therefore the displacement is a 2L by 3. That is the displacement of the ways. पूछा क्या है? Does the combination move the left side? Left side में कितना जाएगा? That is the left में x जाएगा और x की value 2L by 3. So correct option is the third. A uniform chain of mass m and length is a suppose L. Thread touches the surface table by its lower end. Thread breaks suddenly. Find the force exerted by the table on the chain when half of its length. Suppose the total length is a capital N, then the half length of the chain is on the table and half total length is suppose L. This half length is moving with some velocity, that is L by 2. So force exerted by the table is equal to the weight of the chain which is placed on the table, as well as this force exerted by the variable mass. We know the force exerted by chain is a, suppose the velocity is a v and the v is multiplied by dm by dt. Then the weight is only due to this chain जो कि टेबल पे ऑलरेडी रखी है, रेस्ट में है, और बाकी चेन जो L by 2 फॉल हो चुकी है उनकी वेलोसिटी कैलकुलेट करें तो इट इज √2gh के राइट इज इक्वल टू L by 2, so the velocity is a √gl. Then the weight of this part is equal to mg by 2 plus v, that is dm by dt. If we introduce the dl by dt, then this becomes velocity. So the force on the chain by the table is equal to mg by 2 plus this is a velocity of chain, so it is a v square dm by dl. And we know dm by dl is a mass per unit length which is equal to m by l. Then it is a mg by 2 v square means it is a gl plus dm by dl is a mass per unit length. So the total force exerted by the table on the chain is equal to the mg plus mg by 2, so it is 3 by 2 mg. Correct option is the second one. In this question, a cubical block of ice of mass small m and the age of the capital L is placed in a large tray. Very first thing, the large tray of the mass of capital M. When the ice melts, then the डिस्प्लेसमेंट ऑफ द सेंटर ऑफ मास फाइंड करना है। तो शुरू में ये मान लूँ मैं, इट इज़ अ लार्ज ट्रे, दैट इज सेंटर ऑफ द ट्रे, एंड सेंटर ऑफ द आइस क्यूब इज़ अ C2। देन सिस्टम का सेंटर ऑफ मास इनके बीच कहीं होगा यहाँ, और जितना ये हाइट पर है, आइस के मेल्ट होने पर कंप्लीट displacement of the center of mass will be x. Then we know that the center of mass of the ice cube is at the L by 2. So this is a L by 2 minus x. Then when the ice completely melt हो जाएगा तो उसके बाद displacement of the center of mass is equal to x. So very first it is a capital M into x equal to small m into L by 2 minus x. So small m L minus 2x is equal to capital M into x. So twice of capital M x plus of twice of small m into x equal to m into L. The displacement of the center of mass in the downward direction is equal to x, and that is equal to small m into L डिवाइड बाय 2 कॉमन ले लिया जाए, स्मॉल m प्लस कैपिटल M। यानी शुरू में सेंटर ऑफ मास इस जगह था, इस लार्ज ट्रे में इस लार्ज ट्रे में जब आइस क्यूब कंप्लीट मेल्ट हो जाएगा तो कितना नीचे की तरफ डिस्प्लेसमेंट होगा, दैट इज x। सो आई थिंक करेक्ट ऑप्शन इज अ फर्स्ट वन। क्वेश्चन के टू पार्टिकल्स A एंड B, द पार्टिकल्स ऑफ masses आर 1 and 2 kg। सो दिस इज a 1 kilogram, this is a 2 kg, and the speed is a 200 meter per second upward, and that is a 85 meter per second downward direction. Then find the center of mass, initial position of the center of mass. Assume that find the height attained by the center of mass of the particle A and B from the initial position. If we calculate the initial position, then the separation between the particles is 90. This mass is a 1, so the initial height of the center of mass will be, that is a 60 meter. Then relative acceleration की बात करें तो relative acceleration दोनों का g है, so the relative acceleration is a g downward. relative velocity की बात करें, या यूँ कहते हैं सेंटर ऑफ मास की बात करें, सेंटर ऑफ मास की वेलोसिटी की बात करें, नॉट रिलेटिव, इट इज एक्सेलेरेशन ऑफ द सेंटर ऑफ मास की बात करें तो एक्सेलेरेशन ऑफ द सेंटर ऑफ मास इज इक्वल टू 1g डाउनवर्ड 2g डाउनवर्ड अपॉन 3, so it is g downward, and the velocity of the center of mass is equal to 200 into 1 in the positive side minus 85 into 2 divided by total mass is 3. So the velocity of the center of mass equal to, that is 30 by 3 and 10 meter per second. So height attained by the center of mass equal to the velocity का square divided by 2g, and velocity is a 10, so 10 means 100 by 20, it is a 5 meter. So what is the maximum height attained by the particle from the ground? From the ground is a 60 already पे है और 5 जाएगा, so it is 65 meter. But इस वाले केस में तो ओनली क्या पूछा गया है, द हाइट अटेंड बाय द सेंटर ऑफ मास ऑफ द सिस्टम ऑफ पार्टिकल फ्रॉम इनिशियल पोजिशन, मीन्स 60 के बाद कितनी हाइट जाएगा, सो इट इज़ अ 5 मीटर, सो द करेक्ट ऑप्शन इज अ फोर्थ. With the speed 10 meter per second jumps on to the cart as shown in the figure. Cart is initially rest. So we can say in this system linear momentum is conserved. So initial linear momentum of the boy is a 50 with the speed is a 10. Cart का linear momentum 0 है, and the finally when it jumps onto a cart, the total mass is a mass of the cart is, it is not given, only velocity is given, velocity of the system is given. So the suppose the mass of the cart is m, then what is the total mass after this situation, that is m plus 50, and the common velocity is a 2.5 meter per second. Here linear momentum is conserved, p initial equal to p final. P initial is a 500 and the P final is a 2.5 multiplied by total mass is m plus 50. Then 2.5 divided by 500, it is a 200. So 200 equal to m plus 50. So it is very simple. Mass of the cart equal to 150 kg. So first option is correct.